Hello freshmen. Today we're going to be looking at some different types of equations of lines. Remember, we've been using this point slope form throughout the year. We first looked at in chapter 3, so if you need to go back to chapter 3 you can look it up and do some practice out of that section. We're first going to be looking at finding an equation of a line with a slope perpendicular to 3/2 and through the point -2, 1. So remember, when we use this formula we need both a point and a slope. We have a slope of 3/2, but we want the perpendicular slope to that. Remember, perpendicular slopes are the negative reciprocal. That doesn't mean your answer is always negative. It means it's the opposite sign of whatever you started with. So our slope that we want to use here is going to be flipped over, so 2/3, and opposite sign. So since that one is positive, we'll be making the new one negative. So -2/3 will be the slope we want to use for this question. And we're using the point -2, 1, which we can label x1, y1. So when we look at our equation, now we can plug in. We do y minus y1, which is 1, equals slope -2/3 times x minus x1, which is -2. Just like your slope that we've been doing, don't forget your double negative becomes a positive. So when we rewrite this, it will be y minus 1 equals -2/3 x plus 2. And now, before we just left it like this, but now we're going to go ahead and simplify a little bit. So we're going to distribute the -2/3. Y minus 1 equals -2/3 x plus, or rather minus, because positive times negative will be negative, -4/3. And remember, when we multiply fractions, we put it over 1 and multiply the tops, -2 times 2, and the bottoms 3 times 1. So you'll have -4/3. To finish it up, we'll add 1 to both sides to get the y by itself. So we get y equals -2/3 x plus, rather, minus 1/3. And remember, 1 is the same as 1/1, and to add we need a common denominator. So we multiply times 3 on the top and bottom and get 3/3. So -4/3 plus 3/3 is -1/3, and that's where this nice number came from here. You can also use your calculator to do that. Just make sure you switch it back to a fraction. We don't like to have decimals in our final equations. So that's how we find the equation of a line with a slope perpendicular to a slope that's given to us and through a point. This is very important. We're going to be using it a lot in the equations coming up with our different values that we're finding, our centroids, our circumcenters, and orthocenters. So the second piece is finding the equation of a line through 2 points. So now we're not doing perpendicular, but we haven't been given any slope. So we have 2 points. We can find our slope. Our slope would be, again, this is x1, y1, x2, y2. So we'll take 7 minus 2 over -2 minus 1, which gives us 5 over -3, or -5/3. Okay, so that's going to be our slope. We do not need to change our slope at this point because we're not doing a perpendicular line. That is actually the slope that we're going to be using for our line. So slope is -5/3, and I'm going to use this first point just because it has smaller numbers and they're both positive. You could use this one if you wanted to, but this one just seems a little bit easier, so I'll use that one. So we use our equation again, y minus y1, which is 2, equals -5/3 times x minus x1, which is 1. Again, I distribute, so -5/3 x plus 5/3, and then I add 2 to both sides. And remember, 2 is the same as 2/1. My denominator is 3, so this is the same as 6/3 that I'm adding. So I end up with a result of y equals -5/3 x, and this will be plus 11/3. Okay. And again, you can use your calculator for that. We got that from 5/3 plus 2, which is the same as 6/3 equals 11/3. Okay, so this would be our final answer right here. It's simplified with y equals, okay, and we have our slope, and then we plug it into our point slope form using one of our points. So this was a good review of finding equations of lines, which again is going to be very important in the section coming up. So if you have any questions on these, go back to section chapter 3. It was the last section of chapter 3, and they have perpendicular and parallel lines as well as just plain point slope form. And you can do some examples from there if you need some extra practice. Check your answers in the back of the book. Okay.